Hello everyone, and welcome to lesson 3.4, which is on the distributive property. Now, the distributive property is an interesting property because when we think of it, I like to use the analogy of playing cards. So think that you're sitting around, just imagine that you're sitting around a table with some friends. Maybe you're playing spades, maybe you're playing Uno, maybe you're playing poker even. It doesn't really matter. If you're the dealer, you have all the cards in your hands, and your job is to pass out the cards around the table so all of your friends get the same amount of cards. You're taking what you have and you are spreading it out to each separate person. That is exactly what the distributive property is. The way a problem is written, we have to distribute a number by multiplying, and I will stress that again, we are distributing a number by multiplying, just like you are distributing cards to all of your friends evenly. We don't leave one person out, one person doesn't get something while the other person doesn't. We have to share equally. That exact concept is what distributive property is. And we are doing that distribution through the math operation of multiplication. The reason why I stress that is because when I've seen mistakes with distributive property, people like to distribute to the first thing, but then forget to distribute to the rest of the terms that are in the problem. So, if we can understand the analogy of passing out cards to play Uno or something, then we can understand how to distribute. So let's get into some examples of how to distribute problems here. All right, so our first example is 3, and then parentheses, and inside the parentheses is x plus 4. If we were to read that properly, we would say 3 times the quantity of x plus 4. All right, that's cool. I understand that I have to multiply 3 times everything inside the parentheses, but how do I do that? Well, the best way for me to say to do that is you take whatever you have on the outside of a problem and you multiply it times each term inside the problem. So if I am distributing the 3, that means that I'm going to have 3 times x, and I'm going to have 3 times 4. Because of the problem having an addition sign in the middle, I am also going to have an addition sign in the middle. And so the reason that this is called distributive property is because I am multiplying that 3 times the first term, which was x, and times the second term, which was 4. Once I distribute, it's back to what we've done before, and all we have to do is just simplify. So 3 times x is 3x, and 3 times 4 is 12. That plus sign stays in the middle there, and we're good to go. All right. So now we move on to a problem like number 2. We have a couple different things that we're dealing with, a couple different things that we have to simplify. And now that maybe you can do distributive property and you understand distributive property, you will start to see problems that incorporate things that we have done now in chapter 3 with expressions. Combining like terms is one of those. So anytime you get something like this problem in number 2, don't freak out. I understand that there's a lot more written here. We have variables, we have parentheses, we have a lot of stuff going on. Just take what the problem gives you and just move a step at a time. If you move one step at a time, you are eventually going to get to your answer. So, the first thing that I'm going to look at over here is the 4, and I know that that 4 has to be multiplied times the m, and it has to be multiplied times the 7. So that gives me 4 times m plus 4 times 7, which ends up being 4m plus 28. All right, so now, clearly we are subtracting something. And now that we are dealing with that subtraction, anytime we have a minus sign in front of a number that is going to be distributed, it is our best bet to distribute that minus with the number. So in this case, I'm going to use my blue here to show you that. I want to take this entire piece, right? This entire piece here. And I'm going to distribute that negative 6 to the 4, and I'm going to distribute that negative 6 to the m. And the reason why I am doing that is because it makes everything easier when we go to multiply. And it keeps our terms standard. We don't have to worry about, oh, is this a minus? Do I need to add an extra minus sign? Like, none of that. So, minus 6 times 4. It's going to be negative 6 times 4. And then we're going to have over here minus negative 6 times m. All right, we're going to do just what we've done before. So negative 6 times 4 is negative 24. And then minus negative 6 times m is negative 6m. All right. We can simplify still. If you notice that in this problem, we have a little minus minus action. We know that two negatives make a positive. So when we go to rewrite everything, I can rewrite it as 4m plus 28 minus 24 plus 6m. Right. Just really straightforward. And we're able to do that kind of straightforward because we took that negative. So please, 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 if you ever see a negative in front of a number that you're going to distribute, or a minus sign in front of a number that you're going to distribute that minus as well, or that negative as well. It makes things a lot easier on you. All right, from here, we are in our point of what we done last chapter, or last lesson, where we have to combine like terms. We have our m's, we have our numbers. So by combining like terms, 4m plus 6m is 10m, and then 28 minus 24 is 4. So by distributing, we're able to combine like terms, and then after we combine like terms, we get to our final answer of 10m plus 4. Okay, moving on to our third example, we have 12 times 4 plus 3. So, sometimes we get in the mode of solving these problems and we can do distributive property. Sometimes a problem that looks like distributive property is really just multiplication. If we draw our eyes to the inside of the parentheses, I ask you the question of, can we actually solve that? And before, in problems 1 and 2, you have a variable and a number, a whole expression that you can't simplify. In this example, we have 4 and 3. Sure, we can simplify that. So that problem can just be rewritten as 12 times 7. And 12 times 7 is 84. So, at first glance, we thought we would have to distribute. We could if we wanted to, but we don't have to. Just as a side note, if you had chosen to distribute that problem and done 12 times 4 plus 12 times 3, you would have gotten 48 plus 36, which is still 84. So, it doesn't matter if you choose to distribute or not, but example number 3 reinforces why distributive property actually works. All right, so now we're moving on to our last example of the day, This is kind of a little bit of a repeat of number 2, but I want to give you another chance to look at what happens when there's a minus sign in a problem and how that works. So first things first, we are going to look at our 8. We know that we are going to distribute that 8 to both sides. That's going to give me 8x plus 32. The next part here, which is in blue, I'm going to take that whole minus 3 and distribute it. That's going to end up giving me negative 3x. Negative 3 times 2 is negative 6. Then we can combine like terms. Combining like terms, we have our x's here. We have our numbers here. And all we have to do is write our final answer. 8x minus 3x is 5x. 32 minus 6 is positive 26. So we're done. All right, so hopefully this has been very helpful for you to solve problems dealing with distributive property and how they can become a part of what we do, and also how they can set us up to combine like terms. As you can tell in this chapter, we are building, dealing with expressions, substituting, solving, simplifying, all that type of stuff. Hopefully this has been helpful for you, and if you have any other questions, please let me know.